In this lesson, we are going to be learning about standard scores. Here's an example of where we'd use standard scores. The NCAA required Division I athletes to score at least an 820 on the SAT. In 1999, the scores of millions of students taking the SATs were approximately normal, with a mean of 1,017 and a standard deviation of 209. What percent of all students had scored less than 820? So in our last lesson we learned about the rule of 68, 95, 99, 7. What we did with that is we would take our mean and stick it right in the middle. So let me do that with this data. I'm going to say that my mean of 1,017 goes right here. And then my standard deviation of 209, I'm just going to keep adding. So when I add 209, I'd get 1226, 1435, 1644. So I'm adding the standard deviation each time. Let me just give us our data right here. My sample mean, and then my standard deviation. So here, actually, I have to fix this now because of my AP background. I'm sorry. They said this was the whole population, so I'm going to call this mu, which is what the mean of the population is, just so you can kind of see that, and then the mu standard deviation. We'll just call it that. So when I subtract 209 from each of these, I'd get 808, 599, and 390. So when they ask me how many students scored less than 820, in our last lesson, all the numbers they gave us would have fallen directly at one standard deviation away, so we could say 68% of kids did this or whatever. The 820 is between these two. So I could estimate, but I'm not going to get an exact answer. So when we want an exact answer, which is most of the time, it doesn't work to just do the rule of 68, 95, 99, 7. Not everything fits perfectly one standard deviation away. Sometimes it's half a standard deviation away. And so what we want to do is we want to have a way to standardize those scores. What that means is when you're thinking of, like, SAT isn't something we take an ACT. A lot of people want to know, when I get a 27 on my ACT, is that good? I mean, what does that number mean? So we standardize those scores. We say, well, most kids get a 25. I think that's probably high. And the standard deviation is 1, so where would I land? And you could figure out exactly what percentile you're in. Am I in the top? Am I the 64th percentile? Am I the 97th? Am I the 13th? Wherever you land, you have an exact number of where you are. And that's why you want to use a standard score. So a standard score is the observations expressed in standard deviations above or below the mean. So to find a standard score, which is often called a z-score, so that's the abbreviation we'll use from here on out, it's the observation minus the mean, and then you divide by the standard deviation. So that's the formula we'll use, and we'll be practicing that throughout this lesson. The percentile describes the percent of observations that lie below the given percent. Think about what that means. If someone tells you you are in the 73rd percentile, that means 73% of kids lie lower than you. So you're ahead of 73% of kids. That's what that percentile is telling you. And it's always below. Always below. That's a big deal to pay attention to. So when we're looking at a graph of a normal curve, let's say we're looking at this number right here, when we find our answer, we're going to be finding this here. If they asked for greater than, we'd have to do something special to get the greater than, because that's not what we're given. We're given the below. In this normal curve, we're just going to label percentiles. So here is the 0. At the 0, that's the 50th percentile. Now, this is kind of going off of our rule of 68, 95, 99, 7. One standard deviation away is the 84th percentile. Now, where am I getting that 84 from? If you remember in our last lesson, if we were going to figure out how many were below this, it would have been this 50 plus the half of 68, so the 34. So this is what we did in our last lesson, was divide these up. And if you remember, we ended up getting these numbers. And we did this in our last lesson, so I'm not going to go through and redo this. If you wanted to look at that again, that's something you don't remember, you feel free to re-watch that lesson, because that's all in there. So those are the numbers we got. I think it's helpful to put those, label these down here, just so you can kind of look quickly and see what they are, and hopefully they start to be numbers that you kind of memorize the pattern of, because they are very common, and you'll want to know that. Table B is how we move standard scores to percentiles. You'll notice at the bottom of your notes, there's a calculator stuff that we're going to do also. But before this, it says Table B. You look in the back of your book. Since we don't have a book, we're going to hand the sheet out. So you should have the sheet with you right now. So the same sheet I have here, I just copied onto my smartboard. And you can see what standard score is and what the percentile is. So if your standard score is negative 3.4, what does that actually mean? That means you are 3.4 standard deviations below the mean. So that's how far away you are. Think of that in the graph of a normal curve. Now this is just for normal data. 3.4 is further than this, isn't it? So when you look at that percentile, it gives us a percentile of 0.03. One of the problems with using Table B is that you're going to have to estimate sometimes, and that's okay. If you use Table B, you're not going to be penalized for estimating. And we're going to practice first using Table B, because if we just use our calculator, we don't really understand what we're figuring out. So I want us to really understand what this means, and then we can maybe use our calculator as a shortcut later. So you can see all the standard percentiles are on here. These different standard scores. Notice when I get to the 0, what should I have? 50% of my data is below 0, right? 0 is the mean. Or the median, excuse me. 0 is my median, and my mean and normal data. And then when you look at like 2 standard deviations away, there's that 97.73. So that kind of all relates to our normal curve. Let's actually try some of these now. So let's get to some problems. Here, the SAT mean they're giving us on the back. So ignore the calculator stuff, flip it over, we'll get to that later. For our first problem, they're giving us an SAT mean of 500 and an SAT standard deviation of 100. And then the ACT mean of 18 and the ACT standard deviation of 6. And this is something colleges would use if they are trying to convert SAT scores to ACT scores. Jenny scored 600 on her SAT. Gerald scored 21 on the ACT. Who did better? Good question, right? SAT is a little foreign to us. We're not really sure because most students in our state don't take the SAT. Only if you're going to certain colleges where they require it. And so we don't really, like a 600 doesn't mean something to me. A 21 on the ACT, I kind of get what that means. And hopefully you guys will too, because you have friends taking the test and you talk about it. And you're looking at colleges, so you know which colleges and what they expect for an ACT score to get in. And so that one we get, but we don't really know. I don't know who did Gerald or Jenny do better. I'm not sure what a 600 is on the SAT. So what we do is we standardize these scores. So we find Jenny's Z-score by using the Z-score formula. So we take her value, so her score was 600. We subtract the mean. Well, the mean SAT score is 500, so I subtract 500, and then I divide by the standard deviation, which was given to me as 100. So I'm using this data from up here, because that's the SAT data. When I actually do this math out, which is pretty easy to do in my head, right, I get a Z-score of 1. So Jenny's Z-score is 1. Then I go to Gerald. Gerald, for the ACT, got a score of 21. I subtract that from the mean of 18, and I divide by the standard deviation of 6. So again, I'm getting this data from right here. Now, when I take 21 minus 18, I get 3. 3 divided by 6. Gerald's Z-score is 1/2. So what this tells us is, right now, is 1 better than 1/2? What does this actually mean? Just saying Z equals 1 doesn't tell me anything. You have to actually understand what this is saying. This score of Z equals 1 means Jenny scored 1 standard deviation above the mean, because hers is a positive 1. Gerald, if this is a half, then this means that Gerald scored half a standard deviation above the mean. So both of these kids, both of them are above average, right? They're above the 50th percentile. Who did better then? Well, hopefully, from your understanding, is Jenny did better. Jenny is higher up than Gerald. And we didn't have to actually use our Table B for that. We can just tell by looking at the Z-score. Okay? Now, number 2, same idea, but it says what percent of people scored above 750 on the SAT. So now, what percent of people, when they ask for a percent, that's not a Z-score, that's a percentile, and we get percentiles from our Table B. That's where we look that up, unless we're going to use our calculator later. So before I can do a percent, before I can do this, I have to find the Z-score. So the Z-score of people who scored above a 750. So I'm going to look at 750 as my number. minus the mean of 500 divided by the standard deviation of 100, and I get a z-score of 2.5. Now, I'm going to go to my table B, and I'm going to look at that z-score, where that would be. So I have not table B there. Sorry, I have it back on this notes. Oops. Right here. Here's table B. So right now, I want to look up a score of 2.5. So I'm going to move my thing down to find 2.5. Let me just erase this stuff so we don't get confused by it. 2.5 then is right here. There's a z-score of 2.5. So here is the percentile. So I'm going to copy this onto my problem, 99.38. So hopefully you can see that in your notes too. 99.38 is the percentile. If I write this as my answer, does that make sense? What percent of kids scored above a 750? So if the mean is 500, what percent of kids scored above a 750 on the SAT? You think 99% of kids scored above a 750? That seems a little off, right? Here's why. The word above. Remember what I said when you find your table? What this curve gives me, so here's the mean of 500. Let's say 750 is right here, okay? When I find this percentile, it gives me the below data. It gives me this. So the 99.38 is really this shaded area right here. This is the 99.38. That's the percent of kids who scored below a 750. Well, they didn't ask me how many kids scored below a 750. They asked me how many kids scored above a 750. So when it says above, you have to take 1 minus the percentile. And so I'm going to get a percentile of 0.62%. That's less than 1%, right? Less than 1% of kids scored above a 750. Does that make sense with my picture here? Does it seem like less than 1%? And I sketched, of course. It does, right? 99% of kids scoring above the mean doesn't even make sense. So hopefully, if you don't recognize this, think about if your answer makes sense. For sure, not 99% of kids scored above a 750. When the standard deviation is of 100 and the mean is 500, hopefully you realize that, oh, nope, they said above. I've got to take 1 minus. And that is kind of the tricky part of these, is having to remember to subtract that from 1. So now, number 3, it says, what percent of scores lie between 250 and 450 on the ACT? What percent of scores lie between 250 and 450? So what I would do is I would find the z-score for both. So my z-score for the 250, I'm going to do 250 minus 500 over 100, and then my z-score for the 450. So for this one I get a z-score of negative 2.5, and for this one I get a z-score of negative 0.5. So I'm going to look, so what's happening here, just so you kind of can picture this, we have the normal curve, because this has to be normal data for us to use this. And so I have, let's just put in my mean of 500, and then, you know, we've got like the 400, 600, 700, 300, okay? So there's kind of our curve. We're looking at a score of 250. So the one they're giving us is right about here, and then the other one is a score of 450, so right about here. So between 250 and 450 would be this shaded area here in red. That's what we're looking for. So let's look at their z-scores. So let's look at table B and find the z-scores for these. So table B, I need a z-score for negative 2.5. So negative 2.5 right here. I have a z-score of 0.62. So that is this one right here. This percent and less is the, sorry, not that, the dashed line, is 0.62. Now let's look at my other standard score, so my z-score of negative 0.5. Negative 0.5, right here. That's a z-score of 30.85. So I go to 30.85, so I go back to my problem. This is 30.85 right here. So They want me to figure out what I was just told when I found that is from this dashed line and here, this shade area is 0.62. From this dashed line and everything over is 30.85. So I really need to take out this portion because that's not part of the area I'm looking for. So to find this, I would take my z-score or my percentile. So I'm going to write what these are below them just so we can see. I'm going to take that 30.85 minus the 0.62, and I'd get 30.23. And we're going to round to hundredths, just like we always have. That gives me this area in red. That's my shaded area. So that's what you're finding here. You're finding how many kids, what percent of kids score between a 250 and 450 on the SAT? About 30% of kids. That's what you'd say. Okay, and that makes sense to us. If I would say to people, oh, well, it's a z-score of negative 2.5 to negative 0.5. That's not how we talk. We don't talk that way. That's not how people say. But if I ask you a question, I say, oh, about 30% of people, can you picture that in your mind? Yeah, oh, okay, I know where I'm at now. I'm with about 30% of kids. All right, I get it. Some are lower than me, some might be higher, but I'm about in the 30th percentile. Number 4. What did a person score on the SAT if their standard score is 1.4? So when they give us this, they're telling us the z-score equals 1.4. So I'm actually going to work backwards for my formula. I don't know what the person scored, so we'll call that x. X minus 500 divided by 100 equals 1.4. That equals my z-score. So from here, it's a basic algebra problem. I'm going to times both sides by 100. So I'm going to get x minus 500 equals 140. And then when I add 140 to both sides, or excuse me, add 500 to both sides, I'd get a score of 640. So that person scored a 640 on their SAT. So sometimes if you were given a z-score, you can work backwards to find out that value. Last one we're going to do by hand. What would you need to score to be in the top 1% on the SAT? The top 1% would be what percentile? Would it be the first percentile? No, top 1% is really good, right? So in percentile worlds, this would be the 99th percentile. Okay, 99th percentile. So if I'm trying to calculate that, I'm going to have to look for the z-score. So I'm going to go to my table B and find that z-score. The 99th percentile. So let's look. I don't see it on this one. Go down. 99th percentile. All right here. I don't have an exact 99. I've got 99.18 and 98.93. Here's the problem with table B. This is why we don't always want to use table B. I have to pick either 2.3 for my z-score or 2.4. There is no exact 99th percentile on here. My calculator will do that for me, so that's why we're going to show the calculator next, because that's a good tool also. You don't have to use your calculator, though. I would give you credit for this on your test if you chose not to. So which of these is closest to 99? Well, this is 0.07 away, this is 0.18, so there we go. There's my closest. And we do pick the closest. So for this problem, we'll use a z-score of 2.3. So we'll say that is a z-score of 2.3. So now I can work backwards and do the same thing I did in the last problem. So to be in the top 1%, you'd have a z-score of 2.3, so I'll take x minus 500 divided by 100 equals 2.3. So just like number 4, I just had to go find that 2.3. Times both sides by 100, and then I add 500 to both sides. And to be in the top 1%, I got a score of 730. So now, if you would take the SAT and get a score of 730, you're going to feel really good about yourself, aren't you? I mean, that's awesome. Not many people can do that. In fact, only 1% of people can do that. That's amazing. So now you can put that in perspective of where you're at. Okay, so that's basically our lesson right there. What I want to do now is actually show you how to use your calculator for the same type of problems. So we're going to go back, and you're going to look at that first sheet, and we're going to do problems 1 through 3 with your calculator. There's not a lot of work you have to show, so you'll be fine. So what we're going to do is we're going to punch in. It says to find your area or percent under the curve. Okay, so that's right here. We punch in normal CDF. To do normal CDF, you hit second, comma, vars, which is distribution, and then you hit normal CDF. Mine's not printing very good here. Kind of got crossed out, but that's the word normal. You can see it on your notes. It's the left edge of the standard score, right edge of the standard score. So we have to give it the edge of the standard score. The edge is infinity, isn't it? I mean, it goes on forever. So we'll use the number 1000 for ours. Okay? And then to convert percentile scores to raw scores, we'll use inverse norm. So second, and we'll go through that. So that's where your notes are on that. Let's actually apply it. So let's do, oops, where am I going? Let's do number 1. So Jenny scored a 600 on the SAT. To use my calculator, I'm not going to use it on this one. We wouldn't choose it. Let's do number 2. I'm sorry. This is a bad one for our calculator. We wouldn't actually use our calculator for this. Number 2. Pick the wrong. I meant to go 2, 3, and 5, I think. Number 2. What percent of people score above a 750 on the SAT? So to do this on my calculator, above a 750, I'm going to look for my z-score. So I still find my z-score, just like we always have. That's not going to be different for your calculator. So our z-score that we found for number 2 already was 2.5. Now, on my calculator, I'm going to go second, vars, and then I'm going to push normal. I want you to write this down and not use your calculator now so you have it in your notes. Normal CDF, and I'm going to say it's 2.5 to 1000. Now, they asked above. Since this one's an above of that curve, I want to know from the z-score right here and everything above. So I pick 1000 as my biggest number and 2.5 is my less number. And we'll see another one like that in a minute. So let me show you in your calculator. You're going to go second, and then distribution. You're going to go normal CDF, so see how that's the second one. I hit enter, and then 2.5 was my z-score, and the comma is right above the 7 here, and then I'm going to go to 1000. We're just picking 1000 to kind of represent our forever. Okay, I'm going to close that parenthesis and I'm going to hit enter. I get 0.0062. So now 0.0062 is the decimal. Look at your answer we got for number 2. We put it in percent form, right? So we have to transfer to a percent. So the percent for that would be 0.62%. Okay, and let's write on here. Calculator gives us decimal. So we convert it to percent. Okay, you might want to write yourself a note about that. Now, number 3 on our calculator is going to be, we had a z-score. I'm just going to look at your, holy buckets there, that equal sign. We had our z-scores. We had one that was negative 2.5 and the other one was negative 0.5. So those are our limits. We're looking for the shaded area between those two spots. So we're going to do our second vars again. We're going to do normal CDF, and then we're going to go negative 2.5 to negative 0.5. So on my calculator, I go back to that same spot. Second, normal CDF, negative. Make sure you use the negative key and not the minus key, because that can make a difference. And then negative 0.5. Now this will do all that. Whoops, how about a 5 goes in there? 0.5. There we go. This will do all that subtraction and calculating work for me. Notice it says 0.3023. And we will round to the nearest hundredths again. So when I go back to my notes, the calculator gave me 0.3023. So I put my answer as a percent, and that's the same answer we got by hand. Looks good? Now the one I actually wanted, I typed this up wrong. The one I really want to do on your calculator is number 5. So go to number 5. I'm going to go back to just the 5 we did here. On my calculator to do this now, this is the one where we had to estimate the z-score. Remember we just did that? So we were trying to pick where it should belong. Because I'm using my calculator, I won't have to do that. So when I'm given the z-score, I know the z-score, I'm going to do the inverse norm. So inverse norm, and then I'm going to say what percentile I want to use. So in this case it's 0.99, so write yourself a note here. Percentile. And that's given to you in your notes on the other side, but you might want to put it with the problem also. And then next you do the mean, so 500. So I'm going to make myself a note here, mean. Let me just move this stuff over a little bit, sorry. And then last, I want to put the standard deviation, so 100. And that's the standard deviation. So you remember where that came from. So now on my calculator, it's going to give me a better answer than what I got by hand because I had to estimate by hand. So I'm going to go second vars inverse norm. See how number 3 says inverse norm? And I'm going to punch in the 0.99, comma. Did it show up? No. Comma. 500, comma. 100. Now this is going to use an exact number instead of the estimating from table B. So I get the exact score of 732.63. So back in my notes, I have 732.63. This is the score that would be the 99th percentile. So were we close with our estimate of 730? It's close, but if you want an exact number, that's what we would have come up with. Hopefully those made sense to you. If you need any help with anything, your calculator by hand, just so you know, you're going to get to, I want you to practice some with your calculator, but you also are able to do them by hand. So I want you to be able to do it both ways and kind of understand what you're finding. And tomorrow you will have a worksheet on that. So if you have any questions tomorrow, feel free to let me know.